All right, so we're in section 9.7 where we get to factor special products. If you look here in these three equations, we saw those equations earlier in the section, and they were formulas for us to figure out special patterns when factoring polynomials. We had the difference of two squares, where if we had a squared minus b squared, that ends up equaling a plus b times quantity a minus b. And then we had the perfect square trinomials. If we had a squared plus 2ab plus b squared, that would end up equaling a plus b squared, which this also equals a plus b times quantity a plus b. Same thing goes for the subtraction. If it's a squared minus 2ab plus b squared, that ends up equaling a minus b quantity squared, or a minus b times quantity a minus b. It means the same thing. So today, what we get to do is we're going to be given a trinomial, and we have to be able to reverse FOIL it, and then we get to use one of those three pattern formulas to help us factor out each trinomial. So looking at examples A and B, I have x squared minus 64. So obviously, with there's no x degree in there, automatically I see that this is probably going to be a difference of two squares. The whole a squared minus b squared. It fits the formula, and a in this case would equal x, b in this case would equal 8, because 8 squared would give me 64. So then all I have to do is just write it into the equation, substituting x in for a and 8 in for b. So this would be x plus 8 times quantity x minus 8. Okay. For b, I have my a here is going to equal 3x, because 3 squared gives me 9, and b is going to be 11, because 11 squared is 121. So using the difference of two squares formula, I can say that this is going to be 3x plus 11 times quantity 3x minus 11. Okay. Looking at C, my A is going to be 5x. My B is going to be 7y. So then this can be rewritten as 5x plus 7y times quantity 5x minus 7y. Okay? Excuse me. For these examples, we must use the perfect squares trinomial to help us factor it out. So what I would like to do is like we look at my A and my C. So here it's going to be, or my B, I guess that's what it's called. So here it's going to be A is going to give me X. B looks like the square root of 36 is going to be 6. So I can write this as x plus and plus, and then it'll be 6 and 6. It's got to be the same thing. And then you can double check it by foiling it out. And we realize that when you FOIL it out, it becomes this value here. But we can also rewrite this as x plus 6 quantity squared. Okay. For B, my A is going to equal 5x, and my B is going to equal 2. So I know that they're going to be the same thing, both going to be pluses. So I'm going to write 5x here, 2, and 2. And if I were to FOIL that out, I would get the exact same thing. If I didn't, then it wouldn't be a perfect square trinomial. And then I can rewrite this as 5x plus 2 quantity squared. Here, I have 16x squared plus 56xy plus 49y squared. So my a in this case would be 4x. B would equal 7y. It's just taking the square root of those two values. So when I parenthesize them out, I'm going to get 4x plus 7y times quantity 4x plus 7y. And then I can rewrite this as 4x plus 7y quantity squared. Last thing we have is we can use those special patterns to help us solve equations. So here I have 100x squared equals 169. So like I've said, when we're trying to solve equations here with polynomials, I want to get one side of the equal sign equal to 0. So I'm going to subtract 169 to both sides, which gives me 100x squared minus 169 equals 0. And as I look at that, it looks like the difference of two squares, where a would be 10x and b would give me 13. So I can write this as 10x plus 13 times the quantity 10x minus 13 equals 0. So now all I have to do is use the zero product property and take 10x plus 13 equals 0 and 10x minus 13 equals 0. If I subtract 13 to both sides here, divide it by 10, I get x equals a negative 13 over 10. And in this side, I add 13 to both sides, divide both sides by 10, I get a positive 13 over 10. Okay? So if I look at b, again, I'm gonna add 24x to both sides, which gives me 18x squared plus 24x plus 8 equals 0. Now looking at that, 18 is not a perfect square, neither is 8. But I can factor out a 2 out of here because they're all divisible by 2. So I can go 2 divided by 9x squared plus 12x plus 4 equals 0. And 3 is a square, which is the square root of 3, and 2, the square root will give me 2. So it would be what? A would give me a 3x, b would give me a 2. So I can write this as 2 times 3x plus 2 times quantity 3x plus 2 equals 0. And then I can write this out, well, use the zero product property. I only have to do it with one of them because they're the same thing, and I don't need to write it twice. So this is going to give me a negative 2/3. There'll just be one solution. And that is being able to factor using special products. Hope this helps. Till next time.